Welcome to dear students. Here we are going to learn today the bioinorganic chemistry. This is the part of the CHI 230. Okay, this is bioinorganic chemistry. This is a part of what? CHI 210 section second. So last time we discussed the metallo-biomolecules. This is divided into the two types, protein and the non-protein. From that we start to discuss in detail about the protein. This protein is divided into the two types, that is transport and storage of the protein, and the second one, that is the enzymes. And we already finished the first type, that is electron carriers. In that we learned the iron sulfur protein. Okay, this iron sulfur protein, which is a very important protein used for the electron carrier or transportation and the storage of the electron. Okay, next we are going to learn, that is the metal management. This topic we will learn afterward. Before that, before that we are going to learn the oxygen management. Okay, first of all we are going to learn the oxygen management, and then we will learn the metal management. Oxygen management, that means the number of protein or the biomolecules which are the myoglobin, hemoglobin, hemerythrin and the hemocyanin. These are the oxygen transport and the storage protein. Okay, today we will discuss the two biomolecules, that is myoglobin and the hemoglobin. Here this myoglobin, which contain the metal Fe. Both these biomolecules, that is hemoglobin and the myoglobin, are containing the metal, that is Fe. But what is the difference of that? This myoglobin is the oxygen storage biomolecule, and this hemoglobin is oxygen transport biomolecule. Remember that the questions related to this topic always asked in the examination, also in the net and say exam. So be careful for that. Attend this lecture carefully. Okay, so let's start with this. These are the oxygen binding and the storing biomolecules. They contain a prosthetic group of the three well-known oxygen carrier. The first, here we learn here this hemoglobin, hemerythrin and the hemocyanin, which are the oxygen transport or carrier biomolecules, and this myoglobin is the oxygen storage, and that's why here these are the oxygen carrier biomolecules: hemoglobin, hemocyanin and the hemerythrin. Here this is the structure of the hemoglobin. Remember that all the structure of these hemoglobin, hemocyanin and the hemerythrin are very important. Here always ask in your regular examination their oxidized form and the deoxidized form. Here this is the structure. The first case, this is the hemoglobin. In this form is the deoxidized form, deoxyform. Okay, and here this is the structure of all biomolecules are called as the oxyform. That means in this form the oxygen are binded. Here you can see in the hemoglobin, in the first case Fe, which is in the +2 oxidation state, then in the oxidized form it get converted to the get converted to +3 oxidation state. Okay, here this is the hemocyanin structure. It contains the 2 copper and here 3 units of the histidine. Then after oxygen binding, they can form this 2 copper to this oxygen like this manner, and that's why in the oxyform of the hemocyanin, which contain a 6 unit of the histidine. Remember that this question always here already asked in the net examination. The dash dash histidine units are present in oxyform of the hemocyanin. Okay, there are the 6 units. Okay, this is the hemerythrin. This is the structure of the hemerythrin. This contain 1 2 3 4 5 histidine unit. Okay, and after the oxygenation, here this form a peroxy linkage. Okay, oxygen which is binds together, and here this oxygen and this hydrogen which form a hydrogen bonding. That means hemerythrin has a hydrogen bonding, and here they form a peroxy linkage. Let me see where these biomolecules play the role. Okay, this hemoglobin, you know very well, which is present in all vertebrates. Okay, and they are red in color. Why they have the red in color? Because in the oxidized form of the hemoglobin contains Fe3 plus oxidation state, and that's why here our blood is red in color. Okay, that means hemoglobin which is present in all vertebrates. Next, hemocyanin. This hemocyanin contain what? Copper, not the oxygen. Okay, and these are present in the molluscs. Okay, and that's why here these blood of these molluscans, the examples of molluscans are crab, or the you can say in Marathi gogolgai, snails. Okay, from the here that molluscus has the blood which contain copper, and that is called as a hemocyanin. Okay, this is very light blue in color. Okay, and that's why here in the deoxy form, copper has a +1 oxidation state, and in the oxy form of this hemocyanin, the copper has a +2 oxidation state. This is very important. Okay, asked in the net exam. Okay, here third, that is what hemerythrin. This hemerythrin which contain heme group. Okay, in the first deoxy form, this 2Fe which has what? The +2 oxidation state, and on the after the oxidation, here the one Fe has a +2 oxidation state, and another one has the +3 oxidation state. Okay, that means in the deoxy form, this Fe which is +2 oxidation state, and the oxy form, the one Fe is the +2 oxidation state, and another Fe is the +3 oxidation state. This hemerythrin which is present in the some sea worm. These are present in the sea worm. You can see in this picture. Okay, these are some worm which is in which the hemerythrin biomolecules are present. Okay, what is the function of that? All these biomolecules, these are the oxygen carrier biomolecules. Okay, so let's start with the first biomolecule, that is what? Dioxygen storage in the tissue. Okay, that is called as what? The hemoglobin. Okay, this hemoglobin contains the proximal histidine group, and here the 8 alpha helix structure. Here this is mostly the hemoglobin contains the globular protein. Okay, this protein you can see, this is called as a globular protein, global shape protein, that is called as a globin. Okay, that's why this is the globular protein. Okay, here the single, it contains the single polypeptide chain containing about what? The 153 amino acid. Okay, here there are only one polypeptide chain, that means this is a monomeric polypeptide chain. Okay, contains 153 amino acids. Okay, and here this amino acid on this polypeptide chain contains only single heme unit. Okay, in your exam the question always asks, that is compare between the myoglobin and the hemoglobin. Okay, what is the difference between that? In case of myoglobin, it is only one or monomeric polypeptide chain contains the 153 amino acids. And in the one globular protein, here you can see this is the proteins, globular protein. Okay, this globular protein contains only one or the single heme unit. Heme unit, this is very important, single heme unit, and this is the penta coordinated structure. This having the penta coordinated structure. Okay, let me see the evidence for Fe3 plus in case of oxyhemoglobin and the oxymyoglobin. Here the frequency of the oxygen, this is the structure of myoglobin, where the O2 oxygen is binded. Okay, here this frequency of simple oxygen which is present in the oxyhemoglobin has the frequency what, 1107 centimeter inverse. This question also asked in net set examination. The frequency of the oxygen in the oxyhemoglobin is what, the 1105. And here the frequency of O2 minus, this O2 minus which is present in what, myoglobin. Okay, the frequency of O2 minus is 1145, okay, centimeter inverse, which is very closer to the oxyhemoglobin. And the frequency of simple or oxygen molecule, only the oxygen molecule which is not binded to the any other biomolecules, that time they has the frequency what, 1550. Okay, this difference suggest what, this difference, it suggests the formation of O2 minus, which is a spin half ion in a combination with the low spin Fe3 plus. Why this oxygenated Fe is, which is in a 3 plus oxygen state? Here this is combination with the low spin because oxygen is a strong ligand, and that's why here this Fe3 plus which has a low spin, which is also the spin half, and these two spin can pair, and by what, it is well known called as antiferromagnetic coupling, will be diamagnetic. What happen here, whenever this oxygen which is binded to the Fe, it get converted to what, Fe3 plus. The oxygen is a strong ligand. This is a strong ligand, and that's why what happened here, we will learn this in the next slide also. That's why what happened, this electron which is present, this Fe3 plus, which shows what, D this shows the D660, Fe2 plus. Okay, and that's why what happened here, they are shows here, this is the 2 plus system which is shows the D6 system, and that's why what happened, all they shows the low spin, that means all the electron which are present in the lower energy level, and that's this function is known as antiferromagnetic coupling. Okay, and this will be a diamagnetic nature. Okay, next here we learn the myoglobins. So let me learn the next biomolecule that is called as a hemoglobin. This hemoglobin is a quaternary structure of the protein. Okay, what is the difference? Myoglobin is the what, monomeric structure of the protein, and here the hemoglobin is a quaternary structure of protein. We already discussed the type of the protein. Okay, quaternary means what, 4. Quaternary means 4. Okay, and that means the 4 unit which it joins together. Each unit has a prosthetic group, that is a heme group, embedded in a crevice and partly coordinated by the histidine unit. Let's see in detail about the hemoglobin. Okay, here hemoglobin. This hemoglobin mainly divided into the 2 parts. First, that is called as a heme group, and the second one, that is called as a globin group. I am writing here the spelling, hemoglobin. This word itself introduces heme That means this hemoglobin divided into the two part. First that is the heme and the second one that is what? Globin. Heme means what? This contain the pigment part. Pigment part, that means this is heme group which mainly contains the iron. Okay, this iron in the deoxy form which is present in the Fe2 plus in oxidation state, and another group that is called as a porphyrin ring. Okay, that ring which is binded to this central metal, that is Fe, that is called as a porphyrin ring. This is called as what? Porphyrin ring. Okay, this is the tetrapyrrole structure. For what is the porphyrin ring? This is a tetrapyrrole structure. Okay, I hope you understand what is going on. Okay, here next, that means what? The hemoglobin which are divided into the two part, that is heme and the globin. Heme contains the Fe2 plus and the porphyrin ring. Porphyrin ring is nothing but what? The tetrapyrrole structure. Okay, next, that is globin. Globin means what? This globin is nothing but what? Protein part. This is nothing but what? Protein part. Here this hemoglobin which contain the two types of the protein, and my handwriting is not well, so please understand what I am writing here. Here this globin, it is nothing but what? The proteinous part. This proteinous part contain two type of the protein. The first that is called as alpha chain protein. It contain two alpha chain. We already discussed the alpha structure and the beta structure. Okay, if you see the first and second lecture related to the BIOINORGANIC, and on that lecture I am explaining what is the alpha structure and the beta pleated structure. Okay, I hope you understand what is the alpha structure and the beta structure. If you don't see that lecture, then go through that lecture, then only you can understand the next lectures. Okay, these two alpha chain, and the second that is what? The two beta chain. That means alpha protein and the two beta protein. This globin protein contains two type of protein. Two alpha protein, that is called as a two alpha chain, and two beta pleated structure protein, that is called as a two beta chain. Okay, here the one chain contains 141 what? The 141 amino acid, and here 141 into one chain contain what? 141 amino acid. That means there are the two alpha chain is there. That means 241 into 2, which is equal to what? 282. That means the two alpha chain contain 282 amino acid. Okay, 282 amino acid. Likewise, here two beta protein or beta chains contains, the one beta chain contain 146 amino acid. There are the two beta chain is there. That's why 146 into 2, which is equal to what? 292. That means two beta chain contains what? 292 amino acid. Okay, and if we combine both of these, that means hemoglobin is the bulky tetrameric structure, 2 plus 2. That means what? This is the tetrameric protein. Okay, and here this contain about 574 amino acids. Okay, that's why this is very globular and quaternary structures. Okay, that means here one heme group, here, and what happened here? What happened here? These are the protein structure. Here, if this is the alpha structure, this is the alpha structure which is binded to, this is the alpha structure which is binded to the blue color beta structure, and here also this beta structure which is binded to the alpha structure. Okay, and each protein which contains the one heme group. You can say you can see in this figure, this yellow color is what? Heme group. Okay, this is a hemoglobin. Here also hemoglobin 1, this is hemoglobin 2. In the second another beta plated structure, there is a hemoglobin 3, and here also there are what yellow color, that is hemoglobin 4. This is the prosthetic group. What is the prosthetic group? That means this group, that is hemoglobin or heme part, which is binded to the globular part, that is the proteinous part. That group is called as a prosthetic group. Okay, and here there are the quaternary structure of protein, that is there are the 4 proteins there, and that's why here the 4 protein is binded to 4 heme group. In case of myoglobin, there is only 1 protein is there. This is binded to only 1 heme group. Okay, and here in case of hemoglobin, there are the 4 protein and which is binded to the 4 heme group. Okay, and what is the function of that? This is the oxygen carrier. Okay, here you can see hemoglobin, which is contains the 2 alpha chain and the 2 beta chain, and that's why here these 2 alpha, the 1 alpha chain contains 141 amino acid and 1 beta contains 146 amino acid, and myoglobin contains what? Only 153 amino acid. Here this 4 alpha 1 beta 1 and the beta 2 alpha 2, which is combines together, this is the 4 unit of the hemoglobin, and on this 4 unit there are the 4 heme groups are attached. Okay, here there are the mainly the hemoglobin has 3 types. First, that is called as the hemoglobin A, which is present in the adult. Okay, and this is second type, that is called as a hemoglobin F. Okay, that is called as a fetal hemoglobin. That means this is present in a fetal. Fetal means what? The small baby, or the baby which is in the what? Mother's embryo. Okay, that's why here this is fetal. That means the baby which is very small. At that time, this hemoglobin, the F type of hemoglobin which is present in the fetal, that's why this is called as a hemoglobin F. And here after that, whenever this child get elder, then this hemoglobin changes and the changes to hemoglobin A. Okay, so we will stop here. Next time we will learn the mechanism and the changes at the active site during the oxygenation and the deoxygenation. In today's lecture we stop here. In today's lecture we learn the structures of the hemoglobin and the myoglobins. Okay, how they are differentiated from each other. Okay, in the next time we will learn the mechanisms of the hemoglobin and the disease which can be occurs due to the deficiency of the hemoglobin. Then we will also learn that is the the different types of the hemoglobin, that is a T and different state of the hemoglobin, that is a T and R state, and another the topic. Okay, so we will I am going to stop here. Watch this lecture regularly. If you watch the lecture regularly, then only you can understand what is bioinorganic chemistry. Okay, and this is very simple if you see the lecture every lectures. Okay, and this is compulsory to watch the lecture and attain the marks in the comment box. Okay, I am attending your attendance. Okay, then on that basis I will give you the mark. Okay, so don't forget, see the all lecture, which is very beneficial for you student. Okay, thank you very much for watching this lecture.